Hello and welcome to this video on linear regression. This is a machine learning algorithm, or actually a statistical algorithm that has been used for a very long time. I think it was 19th century that it was developed, like 1850 or something. And that has been very useful in a lot of cases. This is usually the first algorithm that you learn in various machine learning courses. We will go into some theories, you can get some intuition about it, and then later on in the next video we'll go into some coding in Python with scikit-learn so that you will learn how to practically do it. Also, linear regression and a lot of classical machine learning algorithms require more mathematical understanding to understand in depth, at least the level of linear algebra. It's usually like first math course in university. However, I will try to keep it simple. I will state some equations, but I will try to explain it in a more intuitive way. I hope that this will be helpful for your understanding, as you don't need to understand exactly how it works. Instead, you just need to understand some intuition and then when and how to use it. Let's move on. Here I am in the slides, and we can see here linear regression, and what you can see here is a Cartesian coordinate system where you have x as years of education and then y as the income. And basically what this is that we have several x here. This is points, and a point is basically like this. You have, for example, you go out and you ask someone, how many years of education do you have? Okay, they say 1, how much is your income? Is the next question. And they say 20K. Okay, then this is 1 point. And then we ask another one, maybe they have here 5 years of education, or like here somewhere. And how much is your income? Yeah, 5K or something. As you can see, this become another point, etc. We ask several people and we get a lot of different points here. And then what you do is that you find a line, basically, that is approximating all these points. And then you can use this line to predict different types of, for example, you can say, oh, my prediction of someone with 6 years education would be, this much salary here. Which is, you take this and you trace it back and, okay, yeah, 60K, for example. And this is a very simple example. Let's move on and see how the process is done. As I explained before, we make a survey to people to ask how long education they have and how much their income is. We collect data. This is the predict income example, how to draw the line. That is basically what we're looking for. We want to draw a line. Okay, then when you're collecting data, you have here x as the years, y as the income. You have income as, for example, SEK, Swedish crowns. And you have a few data points. Here, someone with 1 year's experience have 20K income. Someone with 3 years experience have 40K, etc. Or as not experience, education length. Then we can draw the line. We'd start with the x-axis, number of years of educations, and we have the income as the y-axis. And then you plot out these points. You can see here, the first point is 1 year education, 20K. And then the second point, 3 years education, 40K. And with this one, you can draw a line. The line is basically like this. This is very simple mathematics. It's y equals to w0 plus w1 times x. W0 and W1, they are constants, and x is the variable. Depending on the W0 will give you the value where x equals 0. X equals 0, then you see that W1 disappears and we have W0. That is W0, actually the starting, basically the starting salary, given that you have 0 years education. As you can see, this model is not very good. This example is not very representative because it's too simple, but just to see that you get to understand the idea. because we will move on to several variables later on. And then the W1, it determines the slope, basically, like how much is the slope? Will it go up here, or will it go like this, or will it go like this? That is W1. What you do, you have slope here, and you have the intersection of the y-axis 0. Okay, W0 and W1, they could be estimated from the data. Let me move myself. I'll move myself down here. Okay, you can see that W1, these two we should estimate from the data. The data is here. We have X and Y. Okay, let's move on. You can see by these 2 points, it's very simple to just draw the line. And when we have drawn the line, we get, okay, W0 as the one that intersects the y-axis here. Yeah, but this is quite simply done with 2 points, because we can draw a line straight through it. And then when we have W0, we can find W1. How about this one? We predict income example. How to draw the line now for best fit of the points. Now we have a lot of points. And then we get a lot of points here. These are data values, each of the points. What do we do? Well, we need to find some kind of mean, some kind of average to draw the line. Let's see here. What you want to do is that you pick W0 and W1 to minimize the error. What do this mean? We minimize error in squares, residual sum of squares. The error is here. You can see there's a difference between this value and this value in the line. And there's a difference between this value here, this point, and this value in the line, etc. You go to each of the points, you find a difference to the line. And then these errors are squared, because if you don't square it, it will just be 0. You minimize it. You minimize the residual sum of squares to find this line. Basically what this means, okay, we find a line that gets the least amount of error. That is the idea. Okay, and let's move on to the number of features. We started with one feature. What we had is we had the income, and then we had X, which was the number of years, because then with the number of years, we can predict the income, number of years of education. How about we have more features? What will happen then? One feature, we get something called simple linear regression, and we get a line like this. And we have n features, we have more features. Oh, sorry. Let me move myself up here. We have n features, then we get multiple linear regression. And this gives a plane instead. We get an n-dimensional plane. And what that means is that instead of a line, we get, for example, like this. When n equals 3, we have a plane that looks like this. And the plane is basically what will approximate these points, because you get points in a lot of dimensions, and then you have some kind of high dimensional plane that will approximate, that will minimize these errors. The idea is still the same. You still minimize the error, you find a plane, and the plane is defined by W0, W1, W2, W3 up to Wn. All these weights are given that you can approximate this plane. I won't go into detail how that works, because that is more a linear algebra course. We'll try to scale off the math in this machine learning course. Simple linear regression and multiple linear regression. That is what you need to know, that these terms exist. Simple linear regression for one feature, and for multiple features, you have multiple linear regression. Okay, predict income example 4. We get more features. For example, you have work experience, you have education years, you have area, and you have income. I haven't stated them out here, but these are different type of features that might affect your income. You survey, you ask different things for the people to answer, and then you get data points, in this case in 3 dimensions, and then you want to predict the income. Here are the features, and here is the label. This is the label, the one that you want to predict. You use the features to predict, and you have the label. This is also, in machine learning terms, we have something called supervised learning. It means that we have the income because we ask people about their income, and we ask them about the features, and then we use this to basically train our model to learn the parameters which we use to construct our plane. And with this plane, we can predict the income of other values in the features. That is the idea. Unfortunately, we can't visualize more than 3 dimensions. That is the case. We cannot visualize more than 3 dimensions. What you do when you're practically working in Python and learn, you have something called train, test, split. You have a data set like this. And what you do is that you shuffle the data, and then you pick out a part that is for training and one part that is for testing. And the testing data, you can think of it as you lock it up in a stash. You don't open it until the end. You don't touch the testing data. And that is to get more real results, that you don't get data leakage. What you do is that you take the training data, you have a part that is X train, that is X is the matrix for the different features, and then Y train is the label. And then for testing, you have X test and you have Y test. This data you don't touch until the end because you use this for evaluation. What you do is that you train the model with X train and Y train, and then you predict on your X test. You get Y pred, your prediction. And finally, you evaluate and compare against your Y test. When you compare against your Y test, you get evaluation metrics, which you can use to see how good did we do. Can we get better with other models or other parameters, etc. We'll talk about data leakage, and it's when you evaluate on your train data. If you train on the data and you evaluate on the training data, then you get data leakage. And why is that? That is because basically you minimize your error. That is the training part. You want to minimize your error. And if you minimize your error on the training data and then you test on the training data, then you have leaked the data because you leak the data for your test. That you have already trained, you have already seen the data that you will evaluate on. That is wrong methodology because that will cause that you will predict, you will have better results than the performance actually will. What you want to do is that you want to evaluate on unseen test data. This avoids data leakage. This is what you want to do. Yes, and I haven't talked about the evaluation yet, but basically, in theory, I didn't talk about the evaluation, but there is also different types of evaluation metrics that you can use for regression, but I will show that in the coding part. And I want to keep the theory somewhat simpler to give you just an intuitive understanding. But if you want to learn more and actually dive deeper into the mathematics and to understand deeply how linear regression and other machine learning algorithms work, then I truly recommend a resource called ISLR. ISLR stands for Introduction to Statistical Learning by Gareth James, Daniela Witten, Trevor Hastie, Robert Hibshirani, and Jonathan Taylor. This book is really good to learn more about machine learning and learn more about the statistical methods. And also there's there's one that is for application in R, and there's one that is for applications in Python. Just pick the Python version if you're a Python person like me. I hope that you have learned a lot through this video, and see you in the next one where we'll go into the coding part. Yes, see you. Bye.